Okay, picture this. You just finished a really delicious dinner, and you're packing up the leftovers to toss in the refrigerator. You close the door, completely confident that the cold air in there is going to keep your food perfectly safe. But let me ask you a question. Does your fridge actually kill bacteria, or does it just put them to sleep? Today, we are going to challenge a massive assumption you probably have about kitchen safety, and we're going to unravel a truly compelling microbial mystery in the process. Welcome to today's Explainer. I am so thrilled to guide you through the fascinating and honestly slightly terrifying world of a pathogen that completely defies the standard rules of food safety. Okay, let's dive into this. We are going to profile our microbial villain today, Yersinia enterocolitica. Part 1, Meet the Suspect, Yersinia enterocolitica. So let's trace this suspect's origin story. This gram-negative, rod-shaped bacterium belongs to a pretty infamous family tree. Get this, it's closely related to Yersinia pestis. Yes, that is the exact same organism famous for causing the bubonic plague, so it definitely comes from a dangerous lineage. The genus Yersinia was proposed back in 1944, and by 1964, it officially got its own family designation. But remarkably, it flew completely under the radar for decades. It wasn't until the mid-1970s that it was finally unmasked by scientists as a major foodborne threat. Now, what's really interesting about this is its bizarre biological quirk when it comes to movement. At room temperature, so around 22 to 25 degrees Celsius, this bacteria is highly motile. It's active, it's swimming around, it's searching, but the second it enters a warm human host, at around 35 to 37 degrees Celsius, it just freezes up. It completely loses its mobility. It's an incredible, almost counterintuitive environmental adaptation. But here's the catch. To actually launch an attack on us, out of the 11 recognized species of Yersinia, this specific one needs a highly specialized weapon. Microbiologists call it a virulence plasmid. Think of it like an optional upgrade. If the bacteria somehow loses this extra piece of genetic machinery, it becomes entirely non-virulent, literally harmless to humans. Part 2, the anatomy of yersiniosis, symptoms and victims. Let's detail exactly what happens when this pathogen successfully strikes. Its attack profile is actually kind of fascinating, mostly because the symptoms depend heavily on the age of the victim. Babies and children under 5, they're actually the most susceptible group. In these young victims, the primary symptoms are acute gastroenteritis, meaning severe stomach upset and inflamed lymph glands. But when we look at adults, the whole presentation shifts over to really severe abdominal disorders and intense diarrhea. And speaking of those adult symptoms, the intestinal pain, it is no joke. In fact, especially among adolescents and adults, the pain from yersiniosis is so incredibly intense, and it's localized right there on the right side of the abdomen that doctors frequently confuse it with appendicitis. Just imagine a foodborne bug so vicious it sends people rushing to the emergency room, completely convinced they need their appendix surgically removed. Wild, right? To make matters even worse for health investigators, the timeline of this illness is just all over the place. The incubation period can range anywhere from a single day up to 11 full days after you eat the contaminated food. And the illness itself, that can drag on for 1 to 3 weeks. This unusually long and variable lag time makes it a notoriously tricky mystery for health officials trying to trace an outbreak back to the original source. I mean, think about it. Do you remember exactly what you ate for lunch 11 days ago? Probably not. Part 3, the hideouts. Where does it lurk? Before it ends up causing all this chaos in our bodies, where is it hiding? And this brilliantly illustrates our primary suspect foods: milk, pork, and tofu that's been packed in untreated water. Out in the real world, pigs are overwhelmingly the main animal reservoir. They carry the bacteria entirely asymptomatically, meaning the pigs don't get sick at all, harboring it in their intestines and their oral cavity, specifically right on their tonsils and tongues. So, how does it jump from the farm to your table? Well, let's ground this in a real-world event. Back in 1976, there was a major outbreak in the United States that really showed how vulnerable our everyday items are. 220 grade school children were sickened all at once. And the culprit? Chocolate milk. Somehow, the milk either wasn't pasteurized correctly or it was contaminated after the fact. It just goes to show that even a beloved cafeteria staple can harbor a silent threat. Then there's this really fascinating geographical quirk we see over in Europe. In Belgium, yersiniosis is actually incredibly common. The missing link there? It's the cultural practice of eating raw pork. When you combine a bacterium that naturally lives in pigs with a culinary tradition that entirely skips the cooking process, well, those infection rates are naturally going to soar. Part 4, the superpower, thriving in the cold. This is where we uncover the massive twist of this explainer and the completely counterintuitive reason why this pathogen is so uniquely dangerous in our modern kitchens. We need to define a crucial scientific word here: psychrotrophic. This means the organism is capable of survival and active growth at refrigeration temperatures. Remember that fridge we talked about at the very beginning? We all think of the household refrigerator as this impenetrable safe zone, right? But for Yersinia enterocolitica, your fridge isn't a safe zone at all. It's just a chilly buffet. I'm serious, it can actually grow, slowly, sure, but still grow, at 0 degrees Celsius. It has even been recorded growing at a freezing -1.3 degrees Celsius, and it can easily survive being completely frozen solid for extended periods of time. So thinking about throwing that raw pork in the freezer to kill the germs? No way. The extreme cold absolutely does not kill it, it just tests its patience. To put that cold survival into perspective, let's talk doubling time. At a cool 10 degrees Celsius, the bacteria doubles its population in just 5 hours. If you drop that down to a near-freezing 1 degree Celsius, that doubling time stretches out to 40 hours. Yes, the extreme cold slows it down, but it absolutely does not stop it from multiplying while those leftovers are just sitting there in the back of your fridge over the course of a week. Part 5. The Takedown. Defeating Yersinia enterocolitica. Now that we know about its cold weather superpower, how do we empower ourselves to actually fight back? So the crucial point is knowing your defense strategy, which relies on 2 simple things: strict hygiene and heat. Step 1. Prevent cross-contamination. Treat raw pork like a hazardous material in your kitchen. If it touches your cutting board, your knives, or your counters, those surfaces need immediate, thorough sanitizing. Step 2. Temperature. This bug might love the cold, but it is surprisingly weak against heat. You just need to ensure your food reaches an internal temperature above 60 degrees Celsius to reliably kill it off. Standard pasteurization, boiling, frying, they destroy it entirely. It also has a few other environmental weaknesses we can totally exploit. It's highly sensitive to acidic environments, meaning it's completely unable to grow at a pH below 4.6. It also really struggles with high salt. Its growth is slowed way down by salt concentrations of around 5%, and it stops growing entirely if that hits 7%. But hey, quick word of warning here. Please don't rely on modern packaging conveniences to do the heavy lifting for you. While things like carbon dioxide have some inhibitory effect, vacuum packaging and modified atmosphere packaging, they will not stop it. They just slow the growth down. If the temperature is right, the bacteria is still going to multiply right inside that sealed vacuum bag. Let's reflect on this really powerful quote directly from our source material regarding cooked meals. Its presence in cooked foods indicates inadequate heat processing or post-process contamination and cannot be justified. That is a strict, zero-tolerance policy from food safety experts. Bottom line, if this bug is in your cooked meal, an absolutely crucial, entirely preventable safety step was missed along the way. Which brings us right back to where we started today. Knowing what you now know about this psychrotrophic, plague-adjacent pathogen, I'm going to leave you with a final provocative thought. Is your fridge really a safe zone, or is it actually just a slow-motion incubator? Reevaluate how you handle those leftovers. Always ensure your food is cooked perfectly above 60 degrees Celsius, and never take your kitchen's safety for granted. Thank you so much for joining me on this explainer today. Keep questioning, keep learning, and I will see you on the next one.